So what we learned is we learned about rational functions. Let me tell you a bit. So till now we learned rational function basics and about graphing as well. So first of all, we learned how to find the domain of a rational function, which was very easy. So parent function of a rational function is fx is equal to 1 upon x, right? Where x must not be equal to 0 because when x will become 0, function will become undefined. And transformation of the function is fx is equal to, like a upon x minus h and plus k. H is all about how much left and right you are going. K is all about how much up and down you are going. A is all about the vertical stretch. If you put a minus, then that is all about the reflection. Okay, these are the things we learned about. In order to find the domain, what we do, if suppose there is a function, suppose 1 upon, and there is x square plus 12x plus 27. So first of all, we try to find whole or vertical asymptote. And for doing that, what we do, we factor out the denominator and we check out that can we cancel something or not with numerator. If you can cancel something with numerator, that is a whole. If you are unable to cancel anything, put that equal to 0. So that will become a vertical asymptote. I hope you get the point right.
Yeah.
And vertical asymptote and whole, both of them are not the part of the domain. So you have to exclude them from the part of the domain. This was the first thing. The next thing what we learned is, the next thing we learned about the range. For finding the range, I told you that we have to talk about the horizontal asymptote. And for horizontal asymptote, there was three cases. There was case number one, when degree of denominator is greater than numerator, then y equal to 0 is my asymptote. Don't forget to add plus or minus up or down if you're going right. If degree of denominator and numerator both are same, then your asymptote is leading coefficient of numerator and denominator. So you will write leading coefficient of numerator upon leading coefficient of denominator, right? This is how you have to do. And when degree of numerator is greater than denominator, then there is no horizontal asymptote. Get my point? No problem.
Yeah.
So this is what we talked about. Then we learned how to solve the things. In order to solve, there is a simple rule. The trick is you just have to find the factoring of everything. You have to factorize each and everything. And after that, you have to plug in the function and then you will get the answer. I'm just asking some of the question. Okay, just tell me and then I will move ahead. So suppose if there is x square minus 6x minus 5x, I mean, and plus 6 divided by x square minus 4. Okay, first of all, tell me what is the vertical asymptote of this function. If there is a whole, tell me the whole of this function. Then tell me the domain. Then tell me the range, horizontal asymptote, these features. Try this one, please.
So can we say x is equal to 0?
Can we say x is equal to 0? Where I should say that?
No, for to find range.
For finding range, we find the horizontal asymptote, right? So how we find the horizontal asymptote? Which case is this? Case number one, case number two, case number three.
Case
Degree of
number
hmm,
1
degree of numerator and degree of denominator. How they are
are
related?
the same. So case number 2.
Yeah. So what would be the horizontal asymptote?
Uh,
Y is equal
1.
to, correct answer. Y is equal to 1, right? 1 upon 1. Leading coefficient of both numerator and denominator.
Denominator.
1 upon 1, right? Correct. The horizontal asymptote will not be the part of the range. So except the horizontal asymptote, you have to tell the range. So what would be the range?
Negative infinity to
Hmm.
1.
Hmm.
Union 1 to infinity.
Yeah, 1 to infinity. Correct answer. Okay, now how to find the vertical asymptote and whole? We have to factor both numerator denominator, right?
Yeah.
So factor that up. How to factor x square minus 5x plus 6? What to write at the top?
6,
What to write in bottom?
5, 2,
Negative 5.
3,
Yeah, like how to put the signs?
minus
Both are minus, right? Correct. So my numerator is nothing but x minus 2 and x minus 3. Okay, and what about my denominator? What I could write for that? This is x square minus 4. So how I could write for that?
x
Hmm.
minus 4x plus 4,
X minus 4 and x plus 4. 4.
2,
Yeah. X minus 2 and x plus 2. Correct? Okay, now what I could do, can we cancel out something?
minus 2, minus 2,
Like whole x minus 2 or just minus 2?
whole x minus 2,
Okay, yeah. So whatever you cancel, what that becomes?
whole
Whole. So what I should say, whole is at x is equal to
2,
2. Okay, what is my vertical asymptote? Whatever I'm unable to cancel out, and we have to put that equal to 0. So my vertical asymptote is, so what we are
negative
unable to cancel out.
infinity,
Yeah, so x is equal to negative 2, right? If you put this equal to 0, you get x equal negative 2. And if you put negative 2, the denominator becomes 0. And then the function would be undefined. No problem now.
yeah,
Now, what is the domain? Now we know like what is not included in the domain, both whole and the vertical asymptote.
vertical,
So domain is
negative infinity to negative 2,
correct answer negative infinity to negative 2.
negative 2 to 2,
Hmm.
negative 2 to infinity,
2 to infinity. Right. Okay, and how to tell the end behavior? Let us write the end behavior. So let us make a rough graph out of this, right? So end behavior is always reaching towards the horizontal asymptote, always, all the time. So if you have to make a graph, you will write this one like that. This is a horizontal asymptote, right? And your vertical asymptote is x is equal to negative 2. Okay, is there any reflection? No, there is no negative sign at the front, right? So basically the graph would be made in the first quadrant like this, the graph will go, and in the third quadrant, it will go like this. Okay, so now you have to write the end behavior. You don't always have to make the graph, you just have to understand the concept that whenever we are writing the end behavior, it always approaches to your horizontal asymptote. So if I write x approaches to negative infinity, the fx is approaching to, fx is approaching.
positive infinity.
No, you see where the, if you are going to negative infinity, where the graph is approaching.
Oh, that's 2.
No, that's one horizontal asymptote, always,
Okay,
right? Always, all the time. Like you don't have to even bother about that. This is how the end behavior is being found. If you know what's the horizontal asymptote, you know the end behavior as well, right? And when I write x approaches to positive infinity, then fx approaches to,
negative infinity,
no, again one, the horizontal asymptote. You see, you are going to positive infinity, right? Where the graph is going,
1,
one, this line it is approaching both the side, right? So no matter what, if you know the horizontal asymptote, always the end behavior is going to be related to the horizontal asymptote. You understand this, right?
yeah,
So these are the things what we learned in the previous classes. Again, you can check that out. How to find vertical asymptote? We factor the denominator. If we could cancel something with numerator, then we could cancel that out and that become whole, whatever we cancel. And whatever we are unable to cancel out, that is the vertical asymptote. Both whole and vertical asymptote are not the part of my domain. This is important thing to remember. The next thing to remember is domain is important, like you know that. Now, how to find horizontal asymptote? You have to look for the degree of numerator and denominator. If degree of denominator is greater, the value will become smaller and smaller and it will go towards zero. So that is why when denominator is greater, it has the greater degree. Y is equal to 0 is my asymptote, horizontal asymptote, right? When degree of numerator and denominator both are equal, then leading coefficient as we did here. And when degree of numerator is greater, then there is no horizontal asymptote at all. There is a oblique asymptote or a slant asymptote. I'll tell you how to do that later on. Okay, then end behavior is related to directly to horizontal asymptote, and then horizontal asymptote and range are also interrelated to each other. So this is what we learned. You understand? No problem, na?
Yeah.
Correct? Okay, yeah, because I think they will ask you this in the next unit maybe. Now we have to solve the multiplication and the division. Okay, so let us try. These are the question. Okay, they're asking simplify each expression and state when the original expression is undefined. So what is the meaning when they're asking when original expression is undefined? That means
When you don't do anything to it and bottom is equal to 0.
exactly. That means if somebody is asking that, tell me at what point of time the original equation is undefined. In other words, they are trying to find, they're trying to ask,
What is the whole?
and
Vertical asymptote?
exactly. Very good. Understand my point. Without telling the term the whole and the vertical asymptote, they're asking the same thing, right? So let us solve this question, please. Can we factor the numerator? Is it possible to factor out? Or that is already factored? Like in
It's
question
factored.
one, yeah, let us factor the denominator. Okay. So how we could factor the denominator?
12,
Yeah, negative 12 at the top. What to write in bottom?
1.
Correct. In what number to factor?
Uh, -2, -4, or -3, -4.
Minus 3 and
Okay, 4 -3.
plus 4. Correct. Can we use the trick to write the answer? Can you use
Yeah,
the trick? Yeah, correct. So x times x minus 3, x plus 6, and then we have x minus 3, x plus 4. Okay. So now you tell me where the original function is undefined.
x -3.
Yeah. So x minus 3, and so that means you can say when x is equal to 3 or x is equal to negative 4. That's the answer. Understand, right? No
Yeah,
problem, because at x is equal to 3, what is that? That is a
whole.
and x is equal to negative 4 is a
Vertical asymptote.
exactly. I hope you get the point.
Yeah.
Okay, now domain you could write easy. I think you know the division also. Let me go. Yeah, these kind of question we were doing in the last class. I remember. Same thing it is. Now let us try this one, please. This is what we learned, right, in the last class. We have to simplify that. So in order to simplify, what is the rule?
The x
You have to factor each and everything, whatever is in numerator
denominator.
and you see what you could cancel out. And whatever you could not cancel out, just write that. Correct? So let us
Yeah.
factor out. Can you factor this numerator over there?
Yeah.
Let us do that, please. Y square plus 8y plus 15. Correct? What to write at the top?
15.
Okay, in what number? It's easy actually.
Mm,
It's very simple. 15 into 8, 5 and 3, right?
yeah.
So you should write 5 and 3, correct? And therefore you will write, see for this part I'm solving here, okay? Just a second. Y plus 3, y plus 5. Can we factor the denominator over there? No. So that is y minus 6 as it is. Can we factor this one?
Yeah.
So let us do that. Y square minus 9y plus 18. So what I could write?
18,
Mhm.
9,
Negative
uh,
9.
6 and 3.
How to like just 6 and 3 or some sign?
Minus, minus.
Hmm. Can we use the trick?
Yeah.
Can we factor the denominator?
Yeah. Y minus 3, y plus 3.
Yeah. Y minus 3, y plus 3. What we could cancel out? Now check diagonally. Now we check diagonally and up and down, right? So see what we are going to write. It's very easy.
What am I supposed to do?
Now cancel whatever you could cancel out.
Okay.
Cross out.
Y plus 3, y plus 3, y
Yeah,
minus 3, y minus 3,
yeah,
y minus 6, y minus 6,
yeah. What you are left with?
y plus 5 over 0,
Over 0.
over 1.
So no need to write that actually. That's the answer. We don't write over 1, right? We don't write like 5 over 1, just 5, right?
Yeah.
That's my answer. Get my point now how to do this? Is there any
Yeah.
doubt?
No.
Try question number 25. I'm deleting this one, okay? Then I will tell you how to do addition subtraction, which is a bit tough. Try this one, please. So this
Okay.
is division. So, at the end, the division will change into multiplication. This will just
Flip.
reciprocate. Yeah, correct, correct. But first of all, let us, like find the factoring of everything. So we can do this one c squared minus 6x minus 16. So minus 16 into 6, how we can do that?
Mm, 4 and
Mhm. 8 and 2 and minus 2,
minus 2.
right? So what I could write for this? C plus 8 and C minus 2. This is a very simple formula. What is that? In the bottom, what is this formula? How to factor this? C square minus D square. Could we factor this or like nothing could be done over there?
We can.
So what we could write?
Uh, C
Hmm?
plus
Hmm?
CD,
C plus D and
D plus C minus D,
because this is A square minus,
B square.
huh. Okay, put a division sign. Could you factor this? And this is grade 6th factoring, okay? And I told many a time, many people they struggle in this one. I don't know why. How to factor this?
Which one?
This one. C square minus 8C.
Uh,
Yeah. So C, do we have a pair over there? Yes.
no.
Pair means a group of two or like
Yeah.
so. if you have like two terms, right? So factoring always need a even group. And then we always try to take out something common out of that. It's very
So
simple.
we can take
Grade
out
6
C.
actually.
C parentheses C minus 8.
This is what you will write. Simple. Understand.
Yeah.
C minus 8. No problem, na?
Yeah.
And C outside actually. I'm really sorry. This C would be also there. And can you factor the denominator? Is it possible?
No.
No. So we will write as it is. I hope you're getting how we are dealing with these kind of question, right?
Yeah. Now we have to flip it.
Now you have to flip it. So I will write C plus 8 times C minus 2 upon C plus D times C minus D times C plus D upon C and C minus 8. What we could cancel out of this? Not much. Yeah.
Plus D plus D.
Plus D plus D.
C plus D C plus D.
Huh. What else? Can we do something else?
No.
No. Okay. So that's the answer. So, and we don't have to multiply by the way. Okay. Just write as it is. So C plus 8 times C minus 2 upon 2, like C is there, outside I'm writing, and C minus 8, this is like C and minus 8, and then that is C minus D here. So that's the answer. And never multiply, always leave in the factored form only as your answer. Get my point now?
Yeah.
Is there any doubt like how we have to solve?
No.
Okay, just do one more question and then let us go to the next one. These are a homework, I'm giving some of them. Will you be able to do this question? 32 number?
Uh, I don't think so. Yeah.
I think you will be. Why? Because there is a big mark like that, okay? This means, what is that mark means?
Division.
So you don't know like how to factor both numerator, denominator and divide,
Okay.
or know that one.
I
Okay,
know
will
that one.
you
Yeah.
able to do this one? Question 28. Yes or no?
Yeah.
How to deal with this sign negative one over there?
Change everything on inside negative.
Inside negative, like what I would change?
Flip the signs.
Flip the sign or flip numerator, denominator? If I ask you this, okay, 3 negative 1, would you be able to solve this?
No.
Then how you solve this?
1 divided by 3.
1 divided by
3.
3. So did you change the sign?
Yeah.
Like, did you
No.
change the sign?
No.
No. Then what you did?
Flipped.
Huh. Understand, right?
Yeah.
We'll flip. See, let us try that one. That's very simple. These questions are like very simple. Like, I love solving them because, if you are good at factoring, you could just write your answer like very quickly. See, I'm showing you, okay? Or maybe you try these questions by yourself. You know the formula of a cube minus b cube? What is the formula for that? We did not like
Um,
the last chapter was this one only, factoring and all. We were
we
factoring
take out one side.
what we could take out.
So X parentheses, whatever's inside.
Yeah, okay. Like a cube minus b cube formula is like, I'm just asking that formula by the way now.
Oh, okay. So A minus B,
Mm-hmm.
A plus B.
Uh-huh. Cube formula, na? Then you write a square. Okay. Then you write plus ab and then plus b square. Remember this.
Yeah.
No problem, na? You remember this one, right?
Yeah.
So this is how we are factoring, right? Try question number. I think these are easy. This one 35 is easy. 34 is also easy. Why they're easy, I'm saying. It's all about factoring only. Actually, there is nothing like which is different than factoring. Let us do two questions with me. Do 29 and do 34, and then we will go to the next one. Okay, no problem. No?
Yeah.
Yeah, they look tough, but they're not actually. First of all, how to deal with this? How to deal with this negative one?
Flip.
Okay, so I will write x square plus 4x minus 5, correct? And upon 2x square plus 2x minus 12, correct? And then there would be times 2x cube minus 8x divided by, now think, like you have to use all your superpowers for this. Like it's not tough, it's very easy, trust me. But you just have to think a bit, like how to factor the things. If you are good at factoring, then this is easy. Can we factor this? Stop.
Yeah.
Let's try that one. Negative 5 into 4. What to write?
3. No. What? 1 minus 5 minus 1.
Correct. That means you are saying 5 minus 1, right?
Yeah.
Okay. So can we write x plus 5 and x minus 1? Now think about this one, this thing. Think in a better way. It's a easy
What?
question. Now we have to factor everything, right? Correct?
Yeah.
Think about this one over here. The
So we
denominator.
can just 12 and 2
Yeah, that thingy. How to do that?
minus 12 on top.
But we multiply the first and last term. Remember, you remember we have to multiply, like we have to multiply the first and last term.
We can't do the X method.
We can actually do the x method, but what we write at the top, that's the question. If I give you
Mm,
this question, 3x square, okay, minus 10x plus 8, what you will write at the top?
18 or 24.
Huh, understand, right? This is what you write now.
Yeah.
Okay, but before this, is there any way out that we should not have to write the coefficient for x square? Can we take that out? Because that would be very good if we can able to do that. The work will become easy. Can we take 2 common from all of them?
Yeah.
So take out 2. So x square plus x and minus 6. Get this right?
Yeah.
Now you factor. What to write at the top?
6.
Negative 6. What to write in bottom?
1.
1. Now think. That's really easy.
6. Wait. 3 minus 2.
Hmm. And 2 is outside, like 2 as a factor outside, right? So you'll write 2 times and then x plus 3 and x minus 2. Get my point, right? No problem, no?
Yeah.
Okay, now times. How to solve this? Think and tell me. Like it's very important and it's very easy also at the same time. This thing. Is it looking like a cube, anything like that right now? Oh,
No.
it's a very easy one actually. Okay, this is easy one. I was thinking in different manner, but it's very simple. Okay, do we have a pair?
2.
And what else?
8x.
No, what else we can take out common?
X.
Yeah, then what we are left with?
X squared minus 8.
Minus?
4.
Do you know how to factor this as well?
X minus 2x plus 2.
So can we write? I was thinking like a cube. I was thinking, okay, if you take out, then you get a cube. So that's why I asked you a cube minus b cube formula. But right now I realize it's not cube actually. That's just a square. So 2x and then as you told x minus 2 and x plus 2. No problem. No? Done? Correct? Now can you do the denominator? You can do that, right?
Uh, yeah.
So do like this and 35 at the top and negative 2 in the bottom. How we could write?
15, 3, 5, 6, 5, 7.
Very good, correct. So,
5 minus 7.
correct answer. So, how to write the answer? X plus 5 and x minus 7, right? Now, see what could be cancelled out. So, what we can cancel out?
X plus 5,
Hmm.
x minus 2,
Then,
2.
okay. Then,
That's it.
yeah. So, what is my answer? See, there is a x at the top, so you'll write x, right? Correct?
X minus 1,
X
x plus
minus 1,
2,
x plus 2. Done. And in denominator,
x plus 3, x minus 7.
and that is your answer. No problem, na? Done. This is how we are solving, right? I hope you're getting
We
the.
have to, okay,
No, we don't have to distribute and multiply. This is only the way to write the answer. Okay. Like you don't have to then like multiply them.
yeah,
Just leave like that. So no problem, no?
yeah,
Okay, and the vertical asymptotes, as you could see, is negative 3 and 7. So you could write the domain also out of this. I'm deleting this, okay?
yeah.
Can you try this one by yourself in most easiest way you could do?
Which one?
34. If you can tell me everything like I would be writing.
Yeah. So we have to factor the first
Mm-hmm.
minus 32
Mm-hmm.
and then 4.
Mm.
Mm, s-
But that's easy. 8 and
4. 8
and
minus 4.
so what to
So
write for that?
x,
Hmm?
x plus 8, x minus 4
Correct. X minus 4. No problem.
divided by
Hmm. Now over
x,
here we don't have anything like we cannot take out 2, right? So we have to deal with that as well. So what to write at the top
minus 10.
and what to write in bottom?
9,
Then
10 and 1. 10 minus 1.
and see actually over here we have to write the steps because there is a coefficient, right? Coefficient is not 1, correct? So
Yeah,
I will write that 2x square plus 10x minus 1x and
minus
minus
5.
5. Pair them up. So what that is going to become? 2 is common, x is common. So x plus 5. Negative 1 is common, x plus 5 again. So answer is x plus 5, 2x minus 1. No problem, na?
Yeah,
You will write that x plus 5 and 2x minus 1. Done.
yeah.
Now try this one. Think about this. This is very easy. Do we have two?
We can take out
Correct.
3,
Correct. Then what you are left with?
x squared minus
Hmm?
15.
Minus?
15.
No. You divide and check.
Oh, 25.
Now can you factor this more?
Uh, 3 parentheses
Hmm?
x
Hmm?
minus 5, x plus 5.
Hmm. No problem. No? I'm writing that. 3 parentheses x plus 5 and x minus 5. Right. And then denominator. What will be in denominator?
3x squared minus 11x minus
Hmm.
4.
Yeah, so let us factor that out. So you cannot take out anything, so you have to deal with the numbers. Negative 12 into negative 11. What to write?
12?
Yeah, like 4, 3 times 4.
Okay, yeah.
Yeah, so negative 12, and you have to break that into negative 11. So what will come?
Uh, 6 and no.
No, 11 you have to make, na, and that's a 12. So
Okay, so
something related to
12
12 is
minus 1. So
minus
1
12
minus
plus
12.
1, right? Then a negative 11 will come, minus 12 and plus 1,
1.
correct? So that would be 3x square minus 12x, because you cannot use the trick by the way, plus 1x minus 4, no problem.
Yeah.
Get them up. What is common? 3x is common. So that is x minus 4, right? And then plus 1 is common, x minus 4 again, and that is x minus 4, and then 3x plus 1. No problem now. So this is x minus 4 and 3x plus 1. Done. Okay, now what I'm doing, I'm just trying to write the step here itself. Okay, so can we flip this numerator denominator? Can we change this into the time sign, right? And can we flip numerator and denominator? Because I don't have the space, right?
Yeah.
So what will come in numerator? Isn't it numerator will become x cube minus 4x? Because I change this into times and this will flip like this. Correct?
Yeah.
You get my point now? Okay. So tell me what to do with this.
Uh,
You have two terms. That is the basic of factoring.
wait, I can't see the numbers.
Here.
Okay, yeah. Take out x.
Hmm? And then what you are left with? Correct.
X squared minus 4.
Hmm. And then can you do this more?
X minus 2, x plus 2.
So see, I'm doing here, okay? Here I'm writing in times, right? Because I have changed the division sign into times and flipped. So that's why whatever was in denominator, I'm trying to write in the numerator. Because it will take a lot of time if I write like that and try to flip, because that's a big thing. Correct? So x times x minus 2, x plus 2. I think you can see that, right? In
Yeah.
color I'm writing over there. Okay. Now try this one. Now try to be utilitarian. If you could, work with this like in a better way, that would be much better for us. Try this one. Try to take a
Okay.
smart approach in this. Yeah,
Take out 6.
exactly. So take out 6. So what you are left with? Correct answer.
Hello?
Yeah, correct. Your answer is correct. Take out 6, correct?
Okay, so x squared minus 3x
Mm-hmm.
minus 10.
Hmm. Make x negative 10, negative 3. Then how to do this? Negative 10 to negative 3. How we could do that one? Come on, that's very simple. Negative 10, you have to break into negative 3. Okay, try to think in the positive number. Don't try to think in the negative number. You will get the answer. Try to break 10 into 3. Hello, am I audible? Hello, hi, sorry, am I audible?
Hello?
Yeah.
Yeah, I can
So,
hear you now.
yeah, now try
10
to break.
minus 3.
Yeah,
So
like negative.
minus
Hmm?
5, 2. 5 minus 2.
Like plus 2 and minus 5, right?
Yeah.
Correct. So, how to write the answer? 6 parenthesis, and then trick could be used here, x minus 5 and x plus 2. Uh, I'm audible to you, right? Correct?
Yeah.
Okay, so now I'm writing here 6 times, and this is x minus 5 and x plus 2. correct? Now what we could cancel out? What we could cancel out, sorry, is
Uh, we could cancel out minus 5.
like x minus 5, x minus 5,
Yeah.
right? Okay, so
X
x
minus
minus,
4, X minus 4.
yes,
X plus 2, X plus 2.
yes,
That's it.
mm, correct. Okay, one more thing actually. One more,
3 and 6.
yeah.
So 2 is left.
Hmm. Okay, then what's the answer? And okay, one more thing, one more thing. X plus 5 and x plus 5, right?
Yeah.
Okay, then what you are left with? See, this is x and x minus 2, right? So you'll write x. Order does not matter if you don't write like that, then also x plus
X
8.
plus 8.
And in denominator, what you have? 2. Since if I will write the x as a sandwich here, right, it will not look good, right? So that's why I'm writing x outside. Just I'm trying to arrange, okay? Otherwise, if you write x here also, it does not matter at all. Then 2, and then you have 2x minus 1, and then you have 3x plus 1, and that's the answer. Is that tough? Is it tough or you are getting them?
Yeah, I get them.
You get them, no problem?
Yeah.
Okay, now let us go to the next ones. I'm deleting them, okay? Same thing it is. Now addition and subtraction of the rational number. This is very important. Before doing that, okay, yeah, so this is what we have to do as of now. I'll come to this one. Just give me 1 second. Where is domain, range, and everything? Graphing rational function. I'll tell you how to graph. I have told you, but I'll tell you one more time. Since we just have 15 minutes, questions are easy in this. Okay, try this question 37 number. How to do that one? State, domain,
37.
range, identify the asymptotes. Yeah.
Okay.
What is the excluded value?
You're glitching out.
I'm glitching out, but my internet is good this side.
Okay, yeah, now I can hear you.
So try question number 27. Sorry, what I'm saying. 37.
Okay, so plus 2 means 2 up and down.
Hmm.
Minus 1 means left and right.
Okay, that's true, but they're not asking that one. They're asking domain, range, and asymptote. So first of all, find asymptote. What is the vertical asymptote? Vertical asymptote is,
1 minus 1.
or you put equal to 0 now. Your answer is correct actually. Minus 1 or just 1?
1.
X is equal to 1, right?
Okay.
You understand now, like whatever is the
Yeah.
denominator, can you cancel out with numerator? No.
What?
Can you cancel out with numerator? Anything with numerator?
No.
No. So no whole. Whole is not there, right? So that's the asymptote, then vertical asymptote. Okay. What is the horizontal asymptote? Degree of numerator is? Degree of numerator is?
1.
Uh-huh. What is degree means the variable exponent. What is the
So
variable?
6.
6 is variable. We learned this na in the last class.
Oh, I'm thinking of coefficient. Okay, 1.
What is the degree? Degree of 6. Okay, what is the variable multiplied over there if there is no variable?
There's nothing, yeah.
X equal
1.
x0 like that.
Okay.
X0 is 1.
1.
And 6 times 1 is 6 itself. So degree of numerator is 0. Okay.
Yeah.
Degree of denominator is?
Uh, 1.
So which case?
First case.
So asymptote is, horizontal asymptote is? Degree
Mm,
of denominator is greater. That means denominator is a big number. So the value will approach to,
infinity.
if your denominator is a big number, okay, just see this logic. Remember this logic always for this kind of question, okay? I write 5 upon 10, 5 upon 100, 5 upon 1000, okay? 5 upon 10,000 and so on. So when I'm increasing my denominator, what is happening to the value? See the value, what you get here as compared to this. When you increase the denominator, what happened to value? That's the question. Hello, am I audible?
Yeah.
So when you increase denominator, what happened to the value of the number?
It becomes smaller.
And where it is like reaching, where it is going?
0.
Yeah. So that's why this is the logic that when the degree of denominator is greater, asymptote is y is equal to 0. Understand?
Yeah.
So you will write y is equal to 0 is for this part and there is plus 2. That means you moved 2 unit up. So 0 plus 2. So your horizontal asymptote is y is equal to 2. Understand my point, right? Now keep telling me the horizontal asymptote for all of them. They all are the same question. Horizontal asymptote for 31 is
31.
which degree is greater, numerator or denominator?
Denominator.
So what would be the asymptote?
Y is equals to 0.
Is there anything plus or minus?
No.
No. So just y equals 0 is the answer. Okay. Tell me here. 32,
Y equals 0.
33,
Y equals 0.
34. Correct answer. That is also y
Yeah, Y
equals
equals
0.
0.
35
Y equals minus 5.
minus.
5.
Okay. For 36, right? Correct, correct. For 35, your answer is correct for this one. Well done. For 35,
Uh, Y equals minus 1.
correct. For this one, we already have. Okay. 38, 39, 40.
Y equals 3.
Okay.
Y minus 9. Y equals minus 9.
Then
Y equals minus 8.
you understand my point how to do this, right?
Yeah.
100%. So since you know the vertical asymptote, since you know the horizontal asymptote, tell me the domain and range. Tell me the domain.
Uh, Domain.
Yeah, what we exclude from domain?
Negative infinity to 1. 1 to infinity. Union in between.
Yeah, correct answer. Perfect. Tell me the range. Tell me the range.
Negative infinity to 2. Union 2 to infinity.
Correct. Try question number 38, 39, and 40. Quick.
Uh, 38. Okay. Y equals 3 is the
Hmm?
horizontal asymptote.
Okay, what's the vertical asymptote?
Y equals 4.
Y equals 4.
Sorry,
How vertical
x
line?
is equal to 4.
Huh, right. X is equal to 4. Domain.
Uh,
Quick, quick. You already know the vertical asymptote, so you don't have to think much about that.
-infinity to 4 union 4 to infinity.
Hmm. Range.
-infinity to 3
Hmm.
union
Hmm.
3 to infinity.
Hmm. Okay, try these two questions quick.
Uh, 40 or 39.
30, 39 and 40 both.
So vertical asymptote is -9.
Vertical asymptote is -9.
Okay, horizontal asymptote is -9.
Okay,
Vertical
yeah. Like
asymptote
like
is
what -9? Like just -9.
y equals -9, x
Huh.
equals 8.
Huh. Domain.
-infinity to 8, 8 to infinity.
Hmm. Range.
-9 to no,
Mhm.
-infinity to 9, union 9 to infinity.
-9 to infinity. Right. -9. -9 was horizontal asymptote, right? 40, please.
-8 is horizontal asymptote, y equals -8.
Mm-hmm. Correct.
X equals 7 is
Correct.
vertical asymptote.
Hmm. Domain.
Domain is -infinity to 7, union 7 to infinity.
Hmm. Range.
Range is -infinity to -8,
Hmm.
-8 to infinity.
Hmm. No problem na. You remember this is the basic idea. This is the transformation, right? Now you have to see the graph. You have to tell the function. Okay. Write the value of the function they're asking. What? There is no tough question like where you have something tough to do, like holes and all in same question. Okay, yeah, this one looks good only. Graphing they're asking. Okay, yeah. Try this question, please. 21. Here, my question is find domain, range. Okay, one more thing. Sorry, it's right. There is something called zeros. What is that? Zeros, right? What is zeros, by the way? You have to factor the numerator. If you could cancel out something with denominator, then you cancel that out. And whatever you are unable to cancel out, you put your numerator equal to 0. Okay, so when numerator becomes 0, right, at whatever value, that is called 0 of a function, right? Correct? I hope you get.
Yeah,
For example, I'm just giving an example. If you factored out something, you get something like this. And then there is like x plus 5 also, for example. And then you factored out, you got in bottom something like this. Okay, you get the point now?
yeah.
So where is whole? If you get
Uh,
something like this, then where is whole?
y x equals 3,
Yeah, x equals
-3.
whole, right? Because you are able to cancel out. So x equal -3. What is your vertical asymptote?
Uh,
X equals
vertical asymptote is
like
x equals -2.
correct. And see what is in the numerator. Now put numerators equal to 0, and that is called the zeros, right? Of the rational function. So your zeros are You put this one equal to 0, this one equal to 0, get the zeros, right? So x is equal to 3 or x is equal to -5. Get my point now?
Yeah.
So find the asymptote of each and correct. So basically, these are easy questions. So you have to go to the school also, right?
Yeah.
Okay, so just do one question then. Try this one or try number 12. I hope you get the point how to find the zeros and all, right?
Yeah.
So I'm just solving this one because I think we'll get late for the school. So basically, what you have to do is this is like x plus 3 and x plus 3 you could write, isn't it? Right?
Yeah, my laptop died, so I'm just gonna talk on the phone.
Okay, okay, it's all right, no problem. No problem. And
Yeah.
then x minus 5. What is, okay, by the way, what is the horizontal asymptote for this? Degree of numerator is,
2,
and degree of denominator is.
1,
So
third
what is the
case.
what is the horizontal asymptote? This time
What?
numerator is greater.
So y equals -1?
Nothing. There is no horizontal asymptote. When degree
So
of denominator is greater, then y is equal to 0. Right? When degree of numerator is greater than, no horizontal asymptote. None of them have any horizontal asymptote. I mean none of them. Right? I hope you're
yeah.
getting the point. No horizontal asymptote. So vertical asymptote we have, and that is x is equal to 5. Correct? And zeros are, you put the numerator equal to 0, that is called the zeros of the rational function. So x is equal to -3 or x is equal to -3 again. You get the point, right?
Yeah.
So this is how we are doing. No problem, na?
No problem.
So I told you the recapitulation of the concept, and then I told you some more concept, and then I told you how to multiply and divide the rational functions, right? In
Yeah.
tomorrow's class, we will learn about addition and subtraction of rational function, which is very tough, and solving equation using the rational function. These two things. And then in one class, I'll teach you the graphing. On Friday, we will do SAT class. Again on Wednesday, I'll tell you the graphing, and then this unit would be done actually. Okay,
Yeah.
perfect now.
Yeah.
Okay, so let us meet tomorrow at the same time, like in
Yeah.
evening as we meet. Okay. So take care of yourself, Suarez, and have a good day ahead. Bye.
Thank you.
You're
Bye.
most welcome.